Hello, everybody. Welcome to this presentation, this talk about the software-defined vehicle and what we Bosch think that is and should be, and why we think that. My name is Daniel Krippner. I am working for the Connected Mobility Solutions division in Robert Bosch, and I am a tech lead, tech strategist in this project. So that story that I want to talk to you about, about how we got here and to that point where we are now discussing software-defined vehicles. This story essentially begins in 1969. Now, when I put that slide together, my my inner nerd was kind of raising its hand and said, this is going to be the only time in your career where you can actually mention the Apollo program. So here goes, that year. That's a year that I wish I was alive to be a witness of the first human being putting a foot on a non-terrestrial body. But anyways, what also happened in that year was that at the IAA show in Frankfurt, Bosch introduced to the world the first electronics engine control unit, injection control unit. And essentially, that product introduction that started a year-long battle with the division that was doing the mechanical counterpart to this component, obviously. At the end of that battle, the electronics component won. And while we as humanity, we stopped putting people on the moon, a couple of years later, we did not stop putting electronics into vehicles. So, after the engine controller, there came the transmission controller. We added airbag controllers, we added brake controllers, we added infotainment systems, we added instrument clusters, we added body control modules, we added whatever we could think of up till, a couple of years ago, like when we added perfume dispenser control units, everything in between. And coincidentally, what Bosch invented a couple of decades ago again to connect up all of these nice controllers was like the CAN network, right? That was a way to enable functional interconnection between these different electronic controllers and to achieve vehicle-wide functions and data exchange for these boxes. Now, when I entered this industry, my first job after university, we were at a point where end-of-line cars, top-level cars, premium cars, were looking at northwards of 70 or 80 or 90 controllers distributed around that car. And, I was kind of a software guy. I was an IT guy coming into this industry. I had no clue about anything at all. Talking to people, learning things, getting into topics. But at the back of my mind, when I talked about these things and when I saw the architecture diagrams and so on, there was always that little voice that said, okay, I mean, you can do it that way, right? Obviously, it does work. We can put like 80 boxes in a car, wire them up. But wouldn't it be a lot easier on a software management level if we just put in like 2 or 3 real high-end computers and offloaded the majority of those functions onto that, like as in software? Well, that was a long time ago. Actually, this is what's beginning to happen now. So the next generation electronics architectures that all of the major OEMs are designing and preparing right now, these will go live starting in 2024-ish, around the middle of this decade. These electronics architectures will revolve around 1 or 2 or 3 major central computers. And that will enable a lot of simplification of wiring and of putting software functions that especially, that have an integrative character, that talk to different components and that achieve different kind of cross-cutting things in a car, put these into a central place and, avoid a lot of the complications, syncing up and integrating 80 individual boxes as we did it so far. So let's focus on a few centralized vehicle computers for integration tasks, for high-end autonomous driving tasks and things like that. That is accompanied by another mega trend that we are seeing in the industry right now, which everybody's aware of, I guess, and that is the move away from combustion engines towards electric drivetrains. And just, on the level of mechanical complexity of the components needed to control a combustion drivetrain, that complexity is going down by, I don't know, probably an order of magnitude or more. I mean, you still need to control your battery and the charging charging processes around that. You need to control your electric motors, etc., and the cooling system. But just on that level of mechanical, of moving parts and so on, there's a lot less of that compared to the combustion drivetrains that we're used to. So if you take these two things together, we have more and more high-end computers carrying more and more functions. And at the same time, we have a reduction of low-level control loop level functionality for a large part of what made up a car in the past. That means that looking at the overall product value chain of a car, software is becoming a more and more dominant part of that. So that takes us to this discussion here of what are you doing if you want to stay economically feasible around your product. And you're looking at software in those products that you build, and looking at the fact that this software is becoming, a major part of the resources that go into your product. So what you want to do is you want to scale the software. You want to scale the use that you get out of that software. And that means on a high level, you want to be able to reuse as much of that as possible across different vehicle models, different vehicle platforms, across time, which means, across different generations of vehicle models and platforms. And then if we take a step back, there's a lot of functions, a lot of features that we can think of where reuse across brands and even cross segments in the industry makes sense, right? I mean, a perfectly keyless management software functionality, application set, whatever, that is going to cover keyless entry use cases for e-bikes, for cars, for passenger trucks, for construction machinery, etc. So, not all of software functions will fall into that category, but there are some that also really span industry segments. Anyways, this desire to scale software, that takes us to this discussion that we also have seen starting in the last decade, which is separation of hardware from software. And now, that kind of discussion goes down that path that we've seen happening in the personal computer industry in the 80s, 90s, with the advent of, operating systems that enabled ecosystems of application writers. And the same happened in the mobile handset industry in the 2000s. And something like that trend is what's happening, I believe, in the automotive industry and the software in those products in this decade. All right. Now I've spoken about software-dominated vehicles, essentially. Now, what makes a software-dominated vehicle a software-defined vehicle, right? What is that software-defined thing that we've put out as the headline, the headline of this presentation? What we are thinking about is essentially making the different scopes of software, the different technical scopes of systems in a car manageable using unified software paradigms, as is done in most of the rest of the software-related industries today. What I mean by that, in a car, there's a major difference between cars and almost every other consumer product. For example, that is safety and the health of passengers. And that means we have systems in a car that will not live on a Linux consumer grade system, because these things, brake controllers, they work or people die. And there's not a lot of movement there, of room there, to get too creative, let's say. And we have a lot of these functionalities and these requirements on certain in-vehicle features. So that leads us to a situation where there's a lot of different technical scopes in a vehicle. And these technical scopes, that's what I'm trying to kind of hint at with the horizontal boxes on that picture. We have embedded software, the brake controller, for example. At the same time, we have kind of regular operating systems and high-level in-vehicle software runtime stacks, container runtime on a Linux system for the connectivity unit, for example. We do have more automotive-geared middleware, for safety certifiable software functionality. And there's others. This is just a starting point for this kind of discussion. Now, what we want to do across these different technical scopes, we want to think and design and build a unified way to deploy features into a car. It's like we want to have a description, a vehicle as code style description for, I don't know, let's say something like a seat actuation functionality. This feature that includes low-level embedded controller functions that actually actuate the motors of your seat. This includes safety guard style functionality probably that might live on an adaptive AUTOSAR kind of, middleware in a QNX style system. And then this might include a user profile sync service running on a Linux system that's talking to some backend. And that is 3 pieces of software that together make up that feature in a car. Today, these 3 different pieces of software will be associated with 3 completely different technical silos that kind of, give you the process and the technical framework for how these software is managed, like written, tested, deployed, etc. And we want to build a software-defined vehicle where there's a unified way to deploy the seat function feature across all of these technical scopes. So for example, imagine a desired state definition, kind of a deployment.yaml that defines all these features and that you put into a car. And then there's the components distributed there across these scopes that ensure that the right versions of that software, as per your definition, end up running in the right places. And this concept, this idea of enabling these capabilities across these technical scopes, giving us this kind of matrix here, that is what we think when we say software-defined vehicle. This goes for configuration of different software pieces across these scopes that we want to manage and make like unified. This goes for communication between these components. That includes, unifying on APIs and semantic definitions, how a vehicle is represented. Goes for monitoring, goes for safety, and goes for things like security and identity of things. And, we can have lots of debates and discussions about what actually that means on all of these intersections. We will be talking about what are the horizontals that we want to have. We will probably also evolve the verticals going forward. But I just wanted to give an idea of our mental model. And, as I said, what is that software-defined vehicle thing that this is about? Now, some of you might have seen a press release earlier this year, March, April timeframe, where Bosch and Microsoft together, we announced that we are now going to work on a software-defined vehicle as a collaboration. And this collaboration, this is, the starting point and like the source for the idea, the incubator, if you will, for the ideas and for the goals and the visions that I've been trying to describe just now. However, we are very aware, both of us, both of our companies, we are very aware of the fact that we will not, on our own, privately, if you will, solve this issue and build this kind of system and, conquer the world. So what we are saying is, and what we are kind of shouting out as the call to action, we think that this kind of software stack, or this kind of capability matrix, this is something that will only work and that will only really scale across this industry if we build something together in an open source space. We are not going to conquer this problem space with yet another, let's say proprietary stack that a company builds and then tries to sell to everybody else. We want to form a collaboration of open source communities And I've put the key starter ones on here. So obviously the Eclipse Foundation in the middle. The Eclipse Foundation is going to be where we will initiate an interest group soon. Essentially, this is the announcement for the software-defined vehicle interest group at the Eclipse Foundation that's starting in November. And we will be having discussions about what is this SDV thing, you know, what is this matrix that we're looking at? Where do we take this? What are the building blocks that we need and the ones that we have? And what are the things that we need to do to everything, you know, to get to that target that we all have refined by then? This working group, this interest group has the goal also to establish a full working group, an SDV working group in Eclipse, starting probably, you know, Q2-ish next year. We want to, and we are already working with the Covisa, formerly known as SDV Foundation. These guys have a community, especially from the automotive industry, focusing on, for example, semantic definitions of, you know, what makes up a car, what's the core data points that make up a car. And the Covisa, Genevieve are collaborating with the W3C consortium, also, you know, for Web of Things and related standardization around, you know, semantics and semantic stacks that you build on this industry area. So as a starting point with the center of gravity in Eclipse, this is what we are going to do. That's what we are going to try to, you know, put into life, into being. We, in this case, means Bosch and Microsoft, as you know, let's say the kind of the incubating parties. And we are talking to various different other companies that we would very much like to be on board with us. We have been given the declaration of interest from Red Hat, BlackBerry, the QNX guys, and EPAM so far. We are talking to others. There will be other, you know, other partners in this group when it's starting. These are the official ones at this point in time. And we firmly believe that between these strong industry players in the IT, in the automotive areas and everything in between, and between these open source community foundations that we have up there, you know, for IT, for automotive and for the web and everything that W3C stands for, we have a chance of actually, you know, making that SDV thing something that happens, you know, that is a thing going forward, that will hopefully be relevant and that will have reach and impact on this industry. To wrap this off, just as a loose collection of existing projects in W3C, Genevieve, also in Eclipse, that we are already, let's say, working on, using, that are on the table to be part of that portfolio going forward. But this is, as I said, this is a snapshot for right now, and there will be lots more coming, and there's a lot more also in the mix from the partner companies that I've been mentioning, and hopefully a lot more going forward that right now I have no clue about even. All right, thank you very much for listening. Anyone who is even remotely interested in being part of this, please get in touch. As I said, after the EclipseCon, starting in November, we are looking at the first sessions, the first get-togethers, workshops to define what SDV is and where we want to take it and what that working group down the road should be looking like. I'm happy to take any questions and hope to see some of you in SDV going forward. Thank you very much. Hello, everybody. Okay, thank you. Thank you for listening. I've got 2 questions here for now already. First off, quickly, a disclaimer I have to do. So as you can see from the lighting and from my background, the talk just now has been pre-recorded, and at the time of the recording, we didn't yet have the official confirmation from 2 additional partners that were not on that slide. You just saw. These 2 partners are ARM, where we have a kind of mutual membership between SDV and their SOFI initiative, and the other partner that's onboarded since then is SUSE. So like correction to the previous slide, please imagine these guys and their logos on that as well. Okay, question. I've got one question here which says, you said that complexity decreases with the transition from combustion engines to electric vehicles. But with autonomous driving, software complexity may increase again. What's your take on that? How to tackle this? Is that a topic for the SDV initiative too? Okay. Yes, that is a thing. I mean, let's just say that from that kind of nice, somewhat simplistic picture that I've been describing, AD, autonomous driving software stacks, and the reach they have into the car, they, in a lot of instances, they kind of break that simple world, because very, very much of what an AD stack does is safety relevant, which means it will have to have a very close link and live in that world, these lower level or like more safety oriented systems, and will not be easy to kind of take into the management paradigms, etc., that we want to pull across all of that. I think that there will be low-hanging fruit, first of all, for extending the for example, the orchestration and the management of software in those stacks, to also integrate that into an SDV paradigm. So I mean, it's perfectly fine to put the artifacts, the binaries, etc., whatever, the data that AD systems include, to put that under one management control plane, for example, and then be clever about when and why things do get updated, or when they are not getting updated, because right now, the car is driving and it's not safe to do things, and so on. So I believe there's going to be a lot of those kinds of low-hanging fruit where we can extend, for example, basic software management things into that world and into these systems. I also think that the, more functional aspects of what's happening there probably will not be as easy to, let's say, integrate or get into. So I mean, again, there's degrees here, right? So it will be something that probably can happen quickly, is to connect to these kinds of systems and to get events and maybe even data streams out of them for, let's say, delayed processing and maybe some form of analytics and streaming towards backend systems, for example, stuff that does not impact the operations of these systems. So, that kind of thing is going to be also in the cards, I'm pretty certain. And then there will be an interesting opportunity, hopefully, for intersecting the SDV group and activity with a lot of other groups that are out there that are active in that area. We do have the OpenADX working group in Eclipse, who are active in that space, let's say. And then, there's open source, very, very lively and successful open source communities, for example, around the robot operating system, ROS2. And again, I do think there's going to be a huge number of ideas that can be had and of links that can be made to these stacks. So yeah, not a very definitive answer, but as I said, I guess there's a bunch of low-hanging fruits where also AD software will benefit, for example, from one management plane. And then there's probably more interesting functional things down the line that, clever people can come up with and can kind of pull together and, see where that takes us. I hope that does answer that question to some degree. I've got one more in the chat, which is how to join the SDV Working Group. Well, there's a couple of ways. I guess one of them would be to get in touch with, for example, myself or contacts mentioned, hopefully in the context of this slot and the presentation. There is a mailing list for SDV that was set up this week. Don't know, Marco, or maybe I can post the link to that. And then also, since this week, beginning of this week, there's an SDV landing page that's been set up by the Eclipse guys. And that would be, all of these would be starting points to get you into the fold, let's say. But this is kicking off right now, so nobody's missed anything yet. So please look at that landing page, join the mailing list, and maybe get in touch, with myself or anybody else in this context, LinkedIn, etc. We will be very happy to invite you to the foundational workshops that are starting soon. Next question in the chat. Is SDV also considering topics related to IV in-vehicle infotainment or only vehicle functions? Yeah, that's another interesting discussion, I guess. Let us say that at this point in time, and this is my personal opinion, we are not going to focus or, let's say, even compete, quote unquote, with the IVI space. And I mean, my personal opinion, looking at what's beginning to happen out there, Google is having an ever greater impact in that space with the Android Automotive system that they have been working on for many years, and that's gaining traction now. And then, we have probably players coming into this, like, HarmonyOS out of China, for example, who are trying to provide some alternatives, let's say. And I don't think that this kind of playing field, this part of the playing field at this point in time is going to be the most rewarding. And also there's a reason why the SDV Foundation recently, let's say, rebranded and reinvented themselves, moving away from the central focus on IVI systems to more generic, the software-defined vehicle topics, actually, because, that IVI space probably at this point in time is, happening in the scope of the systems that I mentioned. What I think we want to do in SDV, we want to build and maybe provide adapters, data and function adapters on the top of our stack that make it very simple and quick and easy to integrate something like an Android Automotive system into a car, because all the connection points, let's say, all the data streams, etc., channels that this system needs to interact with the vehicle, because we can provide them easily on top of the semantic stacks, etc., that we are building. I think that would be a value proposition for everybody involved. So that would be my take on how we position ourselves as SDV with regards to IVI systems. Okay, Marco just tells me that he's posted the landing page link into the chat. So again, have a look. Content now hopefully to come in the next weeks, starting in the next weeks. Get in touch, use the mailing list, and looking forward to everybody. I don't have any further questions.